Let me get it off my cam thing here. There we go. I want to run that coil with this reed switch here in either a 9-volt or a 12-volt battery. Maybe even something smaller than that, like a AA or something. And we're gonna set up a magnet out here and a reed switch right here on the end. And we're gonna see if we can get it to get moving. I think that's gonna be sweet. All right. So yeah, we're gonna try a 9-volt battery or a AA battery. We're gonna hook this coil up to it and a reed switch, make a nice little closed circuit, and see if we can't get it to spin on like a AA battery. That'd be awesome. Heck yeah. So that coil is 4 layers of 20 gauge. And the first, this is the crazy part, the first 3 layers are uniform. And that last layer is a little messed up. So the layer that you see is not indicative of what the coil is. Although most people, I don't know, you're supposed to. What you see is what you get, kind of, but it's a lot better than what you see. All right, so we got our 9-magnet rotor. Nice. We're going to turn on both. And we're going to spin it. That's awesome. We got both lights on. Heck yeah, man. So this is what the coils are made out of. We got a bifilar coil in the front here that's 24 gauge and 32 gauge. 32 is a trigger. We got that 24 in the drive connected to this long coil in the back, which is part of the drive. It's a 20 gauge coil. 2 layers of 20 gauge. On a soft iron core, which is a 1/2 inch in diameter and 3 inches long. As you can see, it pounds hard and fast. Cool, but I want to work on this thing today. This is 4 layers of 20 gauge. Each layer is taped individually all the way across. So I got good uniformity across 3 layers. And this last layer I just whipped out real quick. So I apologize for anybody who cares. But this coil pounds too. I had it hooked up over here, and it really hits. So I'm thinking a 9-volt battery might be too much. All right, so get the reed switch in. I'm gonna put it right here on the end of the coil, or maybe even on top of this ridge right here. probably gonna have to flip the coil though. I hope the ends are long enough. They look like they're gonna be long enough. But yeah, man, that's powerful. This one over here, that's a 9-magnet rotor that just took off like that. All right, I'm gonna put this on the tripod and try to find a 9-volt battery. Last time I looked, I did not have a 9-volt battery. Let me get the power plugged in. All right. Sweet. Thanks for dropping in, guys. That's pretty cool. Appreciate you. Now I gotta look here. We can just get it out of here. Oh yeah, that's a good 9-volt. Sweet. Hell yeah. All right. So we got our 9-volt battery, and I think what we're gonna just do is glue it to the top of the rotor. I want to get the connector for it though. I have one, I know I do. Yep, here we go. Sweet, that was easy. Yes?
I'm gonna head outside.
Okay. All right, so this might be a dead reed switch. I don't have anymore. We're gonna find out. All right, we're gonna let that marinate a little bit, dry up. So I'm pretty sure I'm gonna need to strip some of the wire here. It's wise. Never put a pin on the ground, or you might step on it. Alright, so we'll hook this up to the negative. Man, this isn't going to work. I don't think. It's not like this. This is a good tester, though. Right. We want to go through the wire first, so there's a little bit of resistance for the reed switch. Might need some more glue here. What it's looking like. But I'm just trying to test it, so. Alright. We need one more clip to make this right. I know where one is. Alright. We don't really need the switch on there, but I'll put it on there anyway. Hopefully it doesn't get in the way too much. See if the reed switch works. Damn, this is gonna be hard without glue. So I think I'm gonna glue it. Damn, I wish it was a fresh reed switch too. So much. So much wishing going on right now. So the reed switch is going across the coil. Alright, I can't hear it, so, oh man. Let's turn it on. Yes,
Did my friend come in?
yes.
Alright.
So yeah, that's gotta go in here now. Yeah, I think the reed switch is bad. I don't hear anything and it's not playing right. That's okay. I gotta buy some. But here, I mean, the coil works really, really good. It just, I need working components. Let me see if I can find something. That's a 9-magnet rotor and it is taken off. That's just with the one circuit on too. That's great. Hey, what's up, my man? I need reed switches. That's the news. But this, I only need to make 2 more coils. The 4 layers of 20 gauge wrapped around 3/4 inch core. I mean, it hits really, really hard. So, you know, easy does it though. I already got, you know, a laundry list of stuff I still have to pay for. Alright, so, but yeah, that would have been great if that reed switch worked. It'd been awesome. But here, let me see if I can't get, I got this one, like really snazzy reed switch that I could try. It's one of these longer ones. God, dude, I don't like these things. When they're in like tight quarters, it really isn't fun. Brilliant. All right. This is probably cold now. What would be interesting to me is if I put, no, I think it's gotta be on the outside, but if I put a magnet in the middle here, and it triggered the reed switch. Yeah, the light's not turning on, so I don't know. Yeah, boo, boo. I mean, you can really tell when it's working, and it's not. So by the time I do this again, I'll probably have more reed switches. I got one more thing I can try. No, it won't work. It's way too big, you know, it's like too big. Nah. Oh man, what I wouldn't give for just one instance. Huh. Think. Uh, yeah, we don't have anything that we need for that right now. But I need to get more wires so I can do another coil, and I need to get some reed switches so I can test this thing out. So this is an SSG circuit working on a 24 gauge drive that's linked to a 20 gauge drive coil. You can see the difference in the two coils. And then 32 gauge trigger. So it's real sensitive. So this is the other one, the opposite of the one that I just did. So yeah, that's just as powerful, if not more powerful than the other one, even though they're identical. I believe that one over there has higher resistance than this one. This one's like a 230 and that's a 460 resistor. Because this one over here only pulls 100 milliamps at like full throttle. And it's working to eliminate this light. The drive coils are not good for generation, even with the soft iron core, because there's just such a little amount of copper that it's not, I mean, it is generating enough to light it up a little bit, but it really just doesn't. Alright, here I have 3 of them actually. Here's a third coil just the same, 32 and 24. That's awesome. So it's supposed to work on 120s. Hello! This is my pulse motors. These are my pulse motors. So what I'm going to do is I'm going to set it up so I'm going to put both drives on at the same time. And the cool part about this is that it's a 9-magnet rotor, so that's an on-off situation. Every time this one's off, this one will be on. And there's like no actual breakage. It kind of eliminates the pulse. I mean, not really, not actually, but you see what I'm saying? Like these two line up with it right here when this one lines up with the magnet. And same difference when this one lines up, it's in between 2 over here. Hola! Look at that. That is amazing. And that's a total of 300 milliamp draw. That's 9 magnets, so that's not like the fastest scenario either. That's pretty good, what are we gonna call it? Magnetic thrust. I mean, it takes off like a champ. I feel something on here. It's got amazing flywheel like capabilities because it's got so much weight on the outer edge that it has the illusion that it's like really heavy. And I mean it is heavy. It's like two pounds of plastic and then the magnets. So it's pretty heavy. Un poquito habla en español. Uh, it also looks like you asked, what is this? Or something like that. That's 1,000 RPMs right there. I don't know, it shakes a little bit, but I think it's pretty cool. I just hold it there because it's really heavy, and if it like jostles the pole too much, it's gonna fly right off of there. Doesn't matter whether it would be enclosed or not, the whole thing would fly off of there. Not just throw a shoe or anything like that. Trust me, I know. Because it'll lean, and then one magnet will fly off, will dislodge, and then it'll be like a 180. I'm gonna pop a squat, make a list of things that I have to, the last thing I got was a printer plate for my 3D printer. And I made these awesome rotors with it. You know, it actually was the problem. Why don't we just join me over here? So First one I made was this one right here, and the holes were a little bit too small, but they're perfect size for these magnets. These are actually cylindrical magnets. So that, I can make a rotor like that, and that would be sweet. Because it'll be evenly spaced, 120 degrees cylindrical magnet strength. And that's literally like 1.5 inches of pushing power or pulling power of neodymium that you have here. Just in a really small confined space. It's a lot like my electromagnets over there. They hit so hard, and it's like, but if you don't have resistance, you end up drawing over an amp. You know, it's they're not easy to maintain unless you run them in series with something else. So yeah, man, these are cool. And I gotta get the right reed switches, and the cost for the ones that I actually need is just stupid, and it's not directly from any major authority, so it's like they're charging $35 for two of them, and I'm like, yeah, no, I'm just gonna do it a different way. So that's hard because the size of these reed switches is like perfect for what I'm doing. And then I'm going to make another rotor altogether with 3 more cores, and I'm going to make a bifilar one to see if there's any chance that through shorting of coils, extra coils, that this thing might not be able to run itself for a little bit. But I don't know enough about it to know. That's awesome. My kids are having fun, I hope. Mm. And it's solid, man. It's the standard. It's the preset design patterns. 2 loops, 15% infill. I think the next one I'm gonna make is gonna be 35 plus. Just saying. Thanks. Really appreciate that. All right, so man, I wish I could like snap my fingers and have everything just come that I needed just be here. Yes, sir. They're PLA. This is one of my favorite ones. My latest one is because it's all glow in the dark PLA. So, like when I get the light off and get it in the dark after, yeah, you know how it works. I mean, I get really excited about something new, uh, and making a rotor that has the coils in the center spinning instead of the magnet spinning is different. It's definitely a different way to do it, and I think if I'm going to run it the right way, I'm going to have to put well, I don't know if I have to put the power on there like I'm doing it, but I think like 3 9-volt batteries, 3 coils, or should I do like 12-volt battery packs? Well, I've had 3 catastrophic failures. Um, I like to do 100% if the print will take off and adhere and print well all the way through. This one's 100%. Whoops. Yeah, this one right here is 100. This one is 15. So, I mean, like this one gets going really fast and anything's loose, there's a chance that you get a catastrophic failure and it just will bust right out of the side. Yep. I did a live stream just the other day where it happened during the live stream. I was running with my 14-inch rotor here, and this one busted out of the tape. It was duct taped down. Boom, flew out. No, oh no, I'm using SSG on the green one right now. But for this design, I'm going to use a reed switch to short coils and to run the drive. Still need to learn exactly how to do that. See, but this is SSG. It's awesome. That's a 9-magnet rotor. This is from the K Energy store. K-Energy.store. Excuse me. I get that wrong a lot. The K-Energy.store is where I got this SSG from. And I've been analyzing it. I need germanium diodes and a few other things, but it's pretty simplistic. Well, I got the ferrite magnets right here, and I got the neo magnets that I'm using on the rotor right now. I use both. I use them mainly in a combination of both. I use the toroid, the big toroid ferrites as a maglev. So I get one of these on the table, and I put one on the bottom of the rotor, and I center it with, where's my tool at? It's around here somewhere. It's just a little disc with a 1/4-inch hole in the center. It magnets around the edge. So I center it on the pole, and it's really good. But you know, if it gets going up around 2,000 RPMs, it'll start to shake. But mainly because it's really high on the pole. And you know, being that high on a 1/4-inch shaft is just, I don't know, it's not smart. But yeah, I use both types of magnets. Here it is. So we just put a toroid on that. It slides right on the pole. Dead center most of the time. So like it being off balance usually isn't a key or a factor until it gets up to really high speeds. Then like every fraction of a millimeter of anything matters. It all matters at really high speeds. It just does. Now this one, I decided to go low center of gravity. I can maglev anyone I want, yeah, pretty much. But I have limited toroids, so I end up shifting them a lot. Like this one used to have one. Right now I just decided to put it on the bottom of the pole. It's just resting there. But here, let's just go through the process once. And I will put this green one up on a pedestal, so to say. All right, so the second one, we reverse it. Let's see, is this right? No. So, let's go to the trash can. All right, so now this is the tricky part. You want it to be still wet by the time you turn around and get this centered on there. So now I just need to remove the disc, and there it is. It's magleved and it's pretty dead center. I mean, you factor in that the table isn't flat. I know, right? I think that's awesome. That's got a lot of momentum in it still. But here, let's get the bumps off. Because then we're going to need to elevate the coils. Oh man, that ceramic bearing keeps popping out of there. It's pretty solid. Yes, this right here is just because there's a hole in the center. Yeah, so just for alignment. Because, I mean, if you think about it, trying to center this without at least some kind of stencil is going to be damn near impossible. Depending on the size of your hole. So, yeah, that's pretty straight. Anybody want to see it? You can kind of see it where the camera is right now. But it's literally kind of straight. At the same time, it looks a little bumpy. I think it's because the glue dried a little bit before I could get it on the pole. Because that's where I see the unevenness is either in the rotor or in the connection to the rotor. Thanks, man. Appreciate that. I think this is awesome. And I think that YouTube has a lot of people like me. At least the genre. The genre has a lot of people, all good people that want to do good things. Yeah, old man builds, man. I been meaning to build a Tesla coil, and he's got a lot of good, useful information on how to do that. He's got like a lot of stencils for the 3D printer, all that good stuff. Yeah, look at that, man. It's still spinning at pretty much the same rate I started spinning it at. I mean, it's got to be going a little slower, but just a little bit. All right, so yeah, man, that's not good. I mean, I'm just gonna put another piece of tape on there, but it's totally revealing the coil at the time, so can't glue it right now. Gotta tape it first. All right, that was easier than I thought. Been going through glue a little bit quicker lately. But I gotta get myself a new like work space, not a space, but just change this completely because it's starting to bug me a little bit. But we still got a little bit ways to go before we're all the way through this. And so we got some big holes, and that's when I changed it the last time. When there were big holes. For the smallest one, power draw, my smallest power draw is definitely less than 100 milliamps. I'd say amps could have been even that, like, definitely, don't remember the exact number because it fluctuates a little bit. Let's say 30 milliamps. And it wasn't so much a small one as the correct amount of resistance, I would say. And it didn't go super fast, but you know, it was enough to generate. Yes.
I go to the park.
Yeah. Yeah. Run to the park. I should probably go outside in a little bit as well. Now we just need a very small fraction of the trigger coil to be hit with the magnetic energy because it's so sensitive. And it took a while. You know, I had to turn it up all the way to like 17, 18, 19 volts before it even registered. So I don't know, like, it's a give and take, give with the amps and the volts. You know, I think amps are cool, but I think you can survive on very low amps and get good generation with very low amps. I wish there was a quicker, cleaner way to do this than using glue. It's gotta be faster though too. It can't just be different. It's gotta be better. Well, bam. We're gonna let that dry up a little bit. That is awesome. Thank you for reminding me of the maglev, dude. That was great. The voltage, like I said, between, I used a bench power supply. I could turn it all the way up to 24 volts without it going above 100 milliamps. So the voltage wasn't really, it was weird to me, honestly, and it's because I put a resistor right in the drivetrain just right in the middle of the drive, and it slowed everything down, but it also reduced the cost of everything by a tremendous amount. Yeah, man, that was. But, you know, like a small one, like a really little one, you know, you don't need a bunch of, like, I mean, this is like probably the smallest one I got. And like, guys like Lid Motor, he works with the really little ones that are like lids to, literally, he makes all of his motors out of lids to bottles. I think that's pretty awesome. Yeah, man, lid motor. He makes some pretty awesome things that powered by solar and, you know, N2222s. Like if I tried to run this with an N2222, I don't think it would work. I mean, maybe it would work. I don't think it would run. I mean, literally without resistance, these are pulling like 1.5 amps. These coils right here are like, you know, unless they're hooked to something else, they draw a lot of power. Uh, Engineering Mindset is a good channel to check out. There's Hall Effect X. He's really good at this stuff. You got Mike Does is another channel. That's MYKE Does. And you know, they all have very educational channels. There's lots of schematics on Mike's channel. I mean, if you're talking about educational resources, those are Old Man Builds. He's an educational resource. And of course, you know, I can guide you to these sources. So I guess I'm a source too. Do I have another stick? I need another stick. Yeah, I do. Good. I'm on top of my game. That's good. Yeah. All right. Not 100%. I gotta untangle that real quick. Don't have enough slack. Oh my God. This is gonna go so like quickly. I'm gonna have to turn it off before it really gets going. But That's all right. See, and this is pretty much all that it takes. Make sure none of these contacts are touching each other. All right, now while that dries up a little bit, all right, thanks XMID, MDI, MDI, XMDI. All right, thanks, my man. Appreciate you. A little dyslexic. I apologize for butchering the name. All right, here we go. See now, like the base of the trigger coil is all you need, and then these elongated coils are lined up directly with the magnets, so that's awesome. So it's riding a little bit higher on the shaft, but I think it's a much smoother ride, honestly. So that's awesome. That'll spin for quite a while. And I only recommended YouTube channels because that's how I learned how to do it. From watching YouTube channels and listening to what people had to say. And I'm blown away with what I've learned. You know, people pay good money to learn how to do this stuff. And if you find the right people online, you can learn it for very little cost. But I mean, if you like doing it and you got a bunch of ideas of your own, you are going to need money to do this. This is not a free hobby whatsoever. I mean, granted, if you got a lot of crap lying around, you might be able to conjure one up. But not everybody has that. You know, not everybody has a garage full of old stuff that they don't use anymore. Not everybody has that. So, I mean, I try to do it as inexpensive as possible. Maybe not the cheapest, because, you know, you get the cheap stuff, it's not going to work. All right? So, you want to go inexpensive. Quality, but, you know, not name brand quality, basically. And so a lot of the times the quality stuff is actually better than the name brand stuff. But you know, the brand name is recognized. So a lot of it's just yada yada yada. Like these transistors that I'm using right here are from Toshiba. And it says Japan right on them. Hey, what's up, Josh? How you doing, my man? Glad you stopped by. This is Papa Bale's pulse motors, and currently we're running a 9 magnet rotor with 1 inch cubes. It's an 8 inch diameter rotor. It's currently magleved or levitated on 2 toroids. So one toroid is down here and the other one's on the rotor. And it basically takes a lot of pressure off the bearings. Not all the pressure, but a lot. And it levitates it, and it being in the air like that removes that pressure. That's like, it's already got a ceramic bearing in it, so that's removing another, what, 5% of the friction, making it 85% more efficient than a regular bearing. Awesome, Josh. Good to have you. That thing is still spinning at a phenomenal rate, man. This is cool. So I'm using an SSG circuit on both these coil arrays. And then a 9 magnet rotor. So we got on and offset. That 180 degrees. I wonder if the relay would work this way. A lot of vibration in the shaft. And I said this thing weighs like 3.5 pounds, so it's like any vibration in the shaft is cause for alarm. So that maglev is going to make the coasting action that much better. And I think coasting is going to be the key to unlocking everything, like what your pulse motor does when it's off, in an off phase, like completely off. I don't mean like it's flipping or flopping or doing whatever it does. I'm talking about when you turn the frickin' power off and it's still moving. What can you utilize from that? Whether it be more motion or electricity that is generated or any of it, it's all going to boil down, I believe, to what happens when the motor is off. And this, of course, is going to go into a sequence of like a relay or something where you are like on for 30 seconds, then you're off, or no, you're on, like the relay is right here. Okay, one's on, then the other one's on, and then they're both off. Okay, and that's how it should go. Because when you first buy a battery and you turn off the power after using it, it'll creep up on its own, just automatically. It'll creep up. After you use it for a while, it won't. But I mean, if you utilize that time in the beginning to have a coasting phase, a third phase of your your sequence, I think it'll go a lot farther. I really do. So, and so I heard a lot of like talk about like what the Earth it really is. If we could talk about the Earth for a second, that's a giant pulse motor, basically. Not really sure how it works, but I'm thinking that if it's a toroidal pulse motor, then the center of the Earth is hollow, or it has some sort of substance in it that would not be red, like it would, like the Earth would think it's hollow even though it's not. And I always like talk about the electronics like they can think, like the electricity can think. That's why it chooses the path of least resistance, because it's thinking, how can I get to the ground as fast as possible? Always. That's its goal. It's like, it reminds me of Happy Gilmore, and he's talking to the golf ball, and he's like screaming at the golf ball, "You too good for your home? Huh? You too good for your home?" It's like, are you too good for your ground? You too good for your ground? Just go where you're supposed to go. And that's what circuitry, I believe, is all about, is trying to reroute rerouting the electricity to go through your circuit instead of straight to ground. And you either do that through connections, or you do it through resistance, or you do it through, there's lots of ways to do it than just making a big long maze to get to the ground. But that would be fun too, make a big, just a huge mess of wires with diodes and resistance and all this other stuff, and you get it to the point where it eventually gets to the ground. And it turns on a couple lights on the way there, some diode LEDs, it just, And I've done all what I've currently accomplished without sticking any of my wires in the ground of the light socket. Because I know that the energy comes back through the ground, of especially the one that's in the wall. So even though it's a ground, you're still getting feedback from it, which will, I believe it'll run your motor. You know, it's that much power. It's not just a little trickle. But I don't know. I've never done it before, and I'm not planning on it unless somebody can like tell me how to do that. I might try it. And it looks pretty simple. You just shove a wire in the ground socket. And it's not cheating. I wouldn't consider that cheating. I would just consider it utilizing, you know, accessible power that, and you should just disclose that you did that. And you know, if you did, then it's all good. And that's how you do it. Like when you have a plug system and you have to plug something in, you can easily rewire that third prong to feed back, to deliver power instead of being your ground. All right. Sweet. My brother's coming over. Hopefully he'll be able to, you know, liven things up a little bit. I don't really feel like talking right now. As you can tell, my voice is very strained. And I've been sick for about a month and just coughing, and it hasn't been any fun. But I'm trying my hardest now to get it out, you know, before everything breaks down. That is so cool, man. I love the maglevs. What just happened? All right, I think that transistor just blew, but you saw the output goes through the roof. Hello, everybody. Welcome to Pulse Motors. This is Papa Bale. We're checking out different coils, different types. When my brother gets here, we're probably gonna either, well, hopefully we'll have some discussion on current events, basically. We'll make it pulse motor topical, but we're gonna be exploring some stuff hopefully. So I think I might have found a problem. going to get a drink in un momento. Let's see here. Why is it doing that? Man. Here we go. Nope. Man. Yeah, that sucks. I'm not just gonna throw transistors at that. Yo. Yo.
I think I might be. What do you got going on? Oh, what up, y'all?
What up? Damn it.
All right, so what you been working on the last 90 minutes?
Well, everything's been working fine up until I'm gonna turn this on the last time. I don't wanna I just wanna leave that alone. So we're gonna switch the topic. I'm gonna put one more transistor in here after tightening all this down. Hold on, maybe that did it. I was hoping, but no. And so I think like the raw electric, those will be good for that. But for like this kind of electric, we gotta have the transistor does the switching instead of like a reed switch. You gotta have it fully functional. But this, I don't know, might be the circuit. It's a little bit older. We got it. What the hell? I'm not even gonna mess with it. That is. You don't want to even know my hypothesis on what that is.
Hypothesis.
This one works good. So I wonder. I got one thing I could try. And that one is really cheap. That's 100 milliamps. Run that one. I'm just gonna do one thing real quick. It'll be. Got one other circuit. Alright, so this will be my final attempt. I wish that these were a little bit easier. To put in these holes. It is 32 gauge, and that is difficult. That's weird. I don't hear anything. But it's drawn 200 milliamps. have one in the box, I'll use it. If not, nope. Gotta see if we can do. Man, no. The answer to your question is no. This is why sometimes I like using reed switches better. They just have to be able to take the heat. All right. Well, thank you all for hanging out. Hopefully, well, I'll make sure there's some stuff to see the next time I come on. All right. Thank you all. Peace out. Bye now.